Hello everyone, welcome back to mathematics class with me, Mem Ruth. So today we will learn about trigonometric equation, and this is the second part. What we will learn in the second part? First, we will solve trigonometric equation which has reciprocal relation. And the second one, we will solve the trigonometric equation with simplification. And the third one, solving trigonometric equation which in non-exact form. Okay, let's get started. For the first one, in solving trigonometric equation with the reciprocal relation, we will solve this example 1. Find the solution of cosecant x equals minus square root of 2 for the interval of minus 180 up to 180 degree. So how to solve it? Let's start. Here, we will recall first the reciprocal relation that we have, since we will convert all become the simple equation of sine x, cos x, and tangent x. So first here we have 1 over sine x, which is cosecant x, 1 over cos x, which is secant x, and 1 over tangent x, which is cotangent x. Okay, from these three we will choose and convert any reciprocal relation into the sine, cos, or tangent. So for this time, we will choose the first one, right? So we will convert cosecant into sine x. Then, here we have 1 over sine x, which equal to minus square root of 2. Please notice this negative value, don't get it wrong. And then for the interval, we also have to make it become in the interval of minus 180 up to 180 degree. Okay then, let's start. For the 1 over sine x equal minus square root of 2. Then now, we can move it, the 1 over to the right side, and we can rationalize it from minus 1 over square root of 2 become minus a half square root of 2. After this, we will have to know that sine will be negative in the third and the fourth quadrant. And also for the sine, we have to know that sine 45 is a half square root of 2. Okay, then we will draw the graph of sine. If it is only up to 180 degree, so we will draw only one hill. So it stopped at 180, and then we continue to the left for the valley, and we stop at minus 180 degree. Then for the 45 degree, we know that the value is positive a half square root of 2, but for the negative a half square root of 2, it will be in quadrant 3 and in quadrant 4. So this is the y equal minus a half square root of 2, which intersects this graph at the third and fourth quadrant. So this is the position of 45 degree, which value of sine is a half square root of 2. And then since it is symmetrical to the left, it will be minus 45 degree here. And then we will go from minus 180 going to the right 45 degree and obtain the minus 135 degree. Then from this graph, we already found that the answer for the value of x in quadrant 4 is minus 45 degree, and in quadrant 3 will be minus 135 degree. Okay, that's our solution for this example. Let's go next to the second example. For the second one, we'll have to solve the trigonometric equation using the simplification. So we need to recall all formulas we have in trigonometry and use it in this kind of example. Let's solve square root of 3 sine x plus cos x equals 0 for the interval of 0 up to 360 degree. So we have to consider how to make this equation become in one term only. So let's rewrite the square root of 3 sine x equal minus cos x. How to make it become one term only? it is not possible in sin x only or cos x only, so we will try to divide both sides by the cos x, for example. Next, the division result, we will have square root of 3 tangent x equals minus 1. So, please notice here that the formula that we use is sin x over cos x equal tangent x. Please recall this formula, and it is very possible for us to use it in any simplification regarding sin x and cos x. Then we will continue. Square root of 3 tangent x equals negative 1. Then tangent x will be minus 1 over square root of 3, or we can rationalize it, become minus 1 over 3 square root of 3. Let's draw the graph of tangent x. This graph of tangent x, please remember, it has two asymptote lines from 0 up to 360 degree. The first one is at 90 and the second one is at 270 degree. And the graph will goes like this, started from 0 to the infinity, and then from minus infinity to 0 increase to infinity, and it is again from minus infinity to 0 at the fourth quadrant. Then for the value of minus 1 over 3 square root of 3, we will have this line which passes through y equal negative minus 1 over 3 square root of 3, and we will confirm here that tangent negative in quadrant 2 and quadrant 4. How to find out those intersection points? The first one, we know that tangent 30 is 1 over 3 square root of 3. Then from this 30 degree, here we can see the intersection with the x-axis of 180 degree. So from this 180 degree, it goes to the left to 150 degree. And for the fourth quadrant, since it is repeating the same pattern periodically at 180 degree, we will obtain the 330 degree from 180 plus 150. Then these are our solutions for the square root of 3 sin x equal minus cos x. The first one, it is 150 degree, and the second one, it is 330 degree. The last example will be trigonometric equation in non-exact form. So let's see, of course here, the value will be not as spatial angles, but we can find it out using the calculator. Let's see this example 3. Find the solution of secant x equal 5 sin 20 degree for the interval of 0 up to 360 degree. So this is how we can solve it. Okay, let's use calculator to calculate the secant x equal 5 sin 20. But before it, we have to use the reciprocal relation to convert secant x into 1 over cos x, right? Okay, then let's substitute secant x using this formula, 1 over cos. Then we will have 1 over cos x is 5 sin 20. Then the value of cos x will be 1 over 5 sin 20. So let's calculate 1 over 5 sin 20. Here, just type 1 divided by 5 times sin 20. And then don't forget to make sure that your calculator is already in degree mode here in this square. Please check the D symbol for the D degree, or you can go to shift mode to set it up. Please choose number 3 for degree or number 4 in radian or in any unit of angles. Here we choose 3 and it already in D symbol for the degree. And we can just calculate and got the answer 0.585, and we can put it here 0.5847 first. And then to find out what is x, we will use the cos inverse. So this is not cos to the power of -1, but this is a symbol of arcus cos of obtaining angle from any ratio value. So when I write it down like this, I will get an angle, and you can just type it at the calculator and obtain the value of x. So the cos inverse is above the cos button. So for shift cos, you can just type it or just click answer for using the previous answer calculation. And here we will have the angle 54.214, or we will take 54.21, and since we know that cos will be positive in quadrant 1 and quadrant 4, we will use the ASTC for quadrant and conversion. So here we already obtained the first quadrant angle. We just need to convert it into the quadrant 4, and obtaining 360 subtracted by 54.21, and we got the answer for quadrant 4, that is, let's calculate it again using the calculator, and the answer is 305.786 here, or you can reduce it into 2 decimal 305.79. That's the solution for the example 3. That's all for today. Let's continue it later to the other form of trigonometric equation. Thank you for watching this video until the end. Keep healthy everyone. God bless you and see you soon. Bye bye.